Okay, this is a video about trying to collect the data and then use it in Weka. So I just had a few students that were interested in using climate change Earth surface temperature data together with CO2 and CGH emission data. So this is from different countries from between these dates. So they wanted to somehow use both of these together. And if we look at the data, so you have to sign in to Kaggle, and then you can download it. So they are here. So I'll extract this, and also this one. So if I look at this one in Excel, you can see that it has the year and the countries. And then if I look at the other, I have, let's see. So there's by city, this is global land temperature by city, by count, by major city, by state, and I think we want by country because the other one is by country. So if we look at that one, so it looks like this. Now, it's hard to use both of these together. First of all, I'm not sure. The country here is not, comes out like this. So even Excel cannot read this. And what you're going to find often, unfortunately, in Weka, is that it's going to have trouble reading strange characters. So these are strange characters, and Excel even has trouble with it. Weka will definitely have trouble with this one. Even this one, just a simple thing as, I think it was line 77. No. Well, anyway, even if you have, say, an apostrophe in a name, that could cause a problem in Weka. So you're going to run into these problems, and part of this week's assignment, or this first project Scrum, is to learn that you're going to face such problems. Now, sometimes you can clean up the data. For example, if I try to open this one, let's try to open this one in Weka. And I have to find it, and I put it on the desktop in here. And I have to select CSV file. And here, so even that one, which didn't apparently have any bad characters, at least we didn't see any at a quick glance, but we get this. So it says, it's kind of confusing, but finally it says, encountered problem on line 54. So if I go and look at line 54, it's not really clear what the problem is, but it's here, and it's probably this apostrophe here. So what I could try to do, one thing, I could just delete this whole row. That would mean I just delete this country's data. That's one way. Or another thing you could try to do is go to find and select over here, go to find and replace. So the problem could be that apostrophe. So I'm just going to replace the apostrophe with nothing. So just a nothing. So it's just going to get rid of the apostrophe. I'm going to get rid of them all. So I'm going to click replace all here. There's only one case of that. I'm going to close it, and I'm going to save. And now I can check to see whether Weka will open it. Okay, so now it opened it. So that can be a kind of problem that you'll run into, but there's sort of many of these textual problems. Now, going back to the situation of working with two separate databases, I don't really recommend that, for at least for the beginning of your project. So we try to stick to just one data set. Now, the other problem with this data is, if I go back to it, is that this is what we call time series data. That's because these are dates. This is time. So now you might wonder why this is all 0. This is about temperature. It wasn't recorded yet, but now if you go towards the these years, you have a lot of non-zero data. In fact, I guess you have all of this is non-zero. So you could say, well, I'm just going to focus on the years from 2000 up or something like that. Nevertheless, this is time series data, and I don't think we're going to have much chance to study about time series data. And so I want to steer you away from working with that kind of data in your project. So we really don't want data that's based on time. So, but on the other hand, as I said to the students, if you go to Weka and you go to Package Manager, and you look up time, hit enter, and down at the bottom there's something called time series forecasting, and we're not going to use it, and I don't really want you to use it in the group project or your individual project, but you could add this in. Well, I already added it in actually, but you could click here and install it, and then you will see a new tab up here called Forecast. So we go back to that data, and I could use this, and there are many functions in here that you can use to deal with time series data, but we're not going to spend time on this. I guess if you wanted to learn how to use it, you'd go here, and you could read about it here. Okay, so the other data set that the students asked me about was this data set here, which is again from Kaggle, and it's called Trending YouTube Video Statistics. So daily statistics for trending YouTube videos. So daily and trending makes it sound like it's time series, but the heart of the data is not really time series, so that would be okay. So if we download the data, or if I look at it, I can see that there's two types of files here. There's CSV files. You can see CSV, CSV, CSV. I guess this is Canada. Maybe this is Germany. I'm not sure. I don't know. France, Great Britain, India, Japan, Korea, and so US and Russia. So these are separate files on trending videos in, I guess, different languages. So, and then down here there are these other files. They end with .json. Now, we're not going to learn anything about those types, that format, but here I've downloaded them. And just to open this up in Notepad++, so this is a kind of, they call it metadata about the files, about the CSV files. But anyway, we are not going to work with this kind of file. So going back to here, I could try and open up one of these CSV files. So if I try to open, let's just look at the Japanese one. Okay, now on my computer, a lot of this doesn't come out right. So it doesn't show up. You can see this is all Japanese, but it's not showing up as Japanese. And I suspect that Weka will also have trouble with this file. So if I try and open it in Weka, I'll get some kind of error. Let me try it. So I'll go back here, open the file, and I'll open up the Japanese CSV file, and I suspect that I'll just get an error. Yeah, so even it says on line 2, it found that it couldn't deal with something even on line 2, and now there's many rows in this data set, and even if I cleaned up the problem on line 2, it's going to have basically endless problems. So I'll close this, and suppose I even try the US one. Okay, so you might think, okay, well, it's US, maybe it's going to be okay. And actually, I opened up the wrong file. Let me reopen it. So this is the actual file. So if you look, you can see that there's video ID, trending, which is trending date, title, channel, category, published time, tags, views, likes, dislikes, how many times it was viewed, how many times it was liked, how many times it was disliked, how many comments. This is like a link to the thumbnail, or like a link to a picture. Comments were disabled, true or false. Ratings disabled, true or false. Video error or removed. And then description. So I look at the description, have something like this, or I have like something like this, or I have something like that. Okay, so first of all, we haven't, and I don't know if we'll have time to deal with textual data. So that's a field that could be called NLP, natural language processing, could be called text mining, but whatever we call it, I'm not sure we'll have time to deal with text data. Of course, it's very interesting. For example, the tags. Well, so this is interesting data. I think this is what is popular on YouTube, and the tags are interesting. They tell you about the video. And then also, well, I don't know, the channel is probably the name of the person who put up the video. The titles are interesting. We want to talk about our marriage, the Trump presidency, and so on. So the titles are also interesting, but as I said, we probably won't deal with text data. So if we try to open up this file, I'm very sure that there are going to be many errors when we try and open it up with Weka. So we might, trying to open it up, Weka might point us to an error. We could try and fix that error or delete that row, but then there'll be another one and another one and another one. And this has many rows of data. It has 40,000 rows. So we're going to have a lot of cleaning up to do. So we could try to do that. But first of all, to avoid having to clean up things that we can't use, we may as well, unfortunately, delete this. And this we definitely don't need, so let's delete that. And the tags, unfortunately, we have to delete because it's text. The published date might not cause any problem. Now, the category is probably something like, we could go back and look in Kaggle and try and see what these categories refer to. This is category number 28, category number 1, category number 25. These are probably things like humor and history and politics and music and so on. They're probably categories of types of video. So that might be interesting for us. maybe that would be something that we would try to predict. But because we're deleting all the textual data, it's probably going to be quite hard for us to predict the category just based on things like views, likes, dislikes, just this numeric data. Probably not going to be easy to do that, so we probably wouldn't be able to do that. If we could include the textual data, then maybe we could predict that, and that could be our class variable. But anyway, we can leave it in because it's just a number. So the channel name, this might have some characters in there that are going to cause problems. We could try to delete, for example, like we just did apostrophes. Now the title is going to have even more problems, and we really can't use it. So I'm just going to delete that. The channel, I think there aren't going to be many repeats in the channel, although maybe some people have many videos that are popular, in which case maybe we should leave this in here, but it's probably going to give us some headaches in terms of trying to import it into Weka. And this is some ID number, which I think we don't need that. So let's delete that. So we could start by trying this data, but I suspect that we'll get problems trying to load it into Weka, but I'll try it. So first I'll save this, and then I'll close it, and then I will try to open it in Weka. So it's this one, I believe. So on line 130, there was a problem. So we can check it and see if we can figure out what the problem is. So 130, I'm not sure. Sometimes it's doesn't count this line because that's the names of the variables. So that could mean that it's on line 131. But let's see. Oh, is there any problem in there? It doesn't look like it. How about in here? So there. So maybe this apostrophe is giving trouble. So we could try, in fact, just to get rid of all the apostrophes by going here. Oops, sorry, that was wrong. By going here and go to find, replace, find the apostrophe, replace it with nothing, and replace all. So there are 478 apostrophes in this column, but I don't think this is going to be sufficient to fix the problems. But let's see. We'll try it. Try and open it again. So now on line 1143, we could try and figure out what that problem is. So it's probably 1142. No. Oh, sorry, 1143. So here, it's 1144, and you can see these are giving it trouble. So I could just delete this row. And I have so many rows of data, it doesn't really matter if I delete something. So, and then I could save it and try again. But on 1353, there's some kind of problem. So this data, this comes from, I don't know how this data was collected. What was it, 1153? Where was it? Again, let me check that again. I don't know how this data was collected, but somehow, 1353, somehow some characters are coming up that Weka can't deal with. And in point of fact, actually, even Excel, at least my version of Excel on my computer, can't deal with it either because it's coming up like this. So I could again delete this. and try again. I guess I have to save it, and then I can try again. But probably there are going to be many cases. So 1593. So you can do this, and if you have to do this kind of cleaning up of the data, you should write about it in your report. That's very important. You might think, oh, the most important thing is explaining the model that you used and giving the prediction results and so on. And of course, that is very important. But reality is that for a data scientist, much of the time, maybe 90% of your time, is spent cleaning up data. So you may not be cleaning it up the way we're doing it right now, and some software is better for accepting data than others, and Weka is particularly bad, particularly weak at trying to deal with any kind of strange data like this. Anyway, you could try to clean up like this. However, as I said, this data only has about 10 variables. 1, 2, 3, 4, 5, 6, 7, 11. 11 variables. So that is not really enough. We'd like to have, say, 15 variables. And these two variables, I'm not really sure how useful they are, but I guess we can consider them variables. Okay? Then, but just to show you that you could open up this file if you cleaned it up, let's just take the first 200 rows and get rid of everything else. Then I think the file will at least open in Weka. So if I select all of this and delete it, and then try to open it now, it should open up. Okay, so it did open up now. So we could try to clean up the data and then try to use it. Okay. Now let's go back, if I can. I guess I can't go back. Now suppose this was what you were trying to predict. You decided that this was going to be your class variable. So you could, so this is a numeric class variable, and I don't think the algorithms we've talked about so far have been good at or useful for, or we haven't talked about how to work with a numeric class variable. So you could try to convert views to a categorical or non-numeric variable. And the way you could do that is you could go to the end of the data. In this case, I don't have much data. And I could calculate the max and the minimum for this column. So I could go to here, for example, and I could get the max. And I could see that the max is this number. I'll just copy it. I'll paste it over here. Maybe this is not a good idea, but I'll paste it over there as a value. And then I could also get the minimum. And it's that. So I know that the data is between 773 and this, which is what? I think that's 33 million. But actually, if I included all the data, it would have a much bigger range. But then what you could do, and I'd like to do this also in Weka, but what you could do is you could convert this to like a categorical variable. What I mean by that is you could type equals to make a formula, and then if, and then you could say if this value, now the highest value is about 33 million, so let's say if this is greater than, say, 10 million, I think that's 10 million, and then you'd say, call it A. Otherwise, if it is greater than, say, 1 million, and call it B. I don't know if I typed in 10 million correctly or not. Otherwise, if it is greater than, let's say 500,000, then call it C. And otherwise, just call it D. Now, you'd probably want to break it down further, but I'm just going to stop there at D. And I have to hit another parentheses, and then another parentheses. Hopefully that's enough. That's the right number. So that would be a C. Really? Okay, maybe. And then you can just copy this, and then scroll all the way down to the bottom. And then I'm holding the Shift key down, and I'm clicking here. And now I'm going to do Control V to paste the formula in there. So now I have a categorical variable. So I've converted views to a categorical variable. So if you need to do that because of the algorithm you're using, you could do something like that. Now, I believe that there's also a filter that we could use for that. And I believe it's called, let's see, I believe that it's in here under attribute. I think it might be this one. So yeah, so let's try that. So this is called Discretize, which means taking something which is a number, like continuous, and putting it into categories, or what they call bins. So let's see, now it says the attribute indices that I want to apply this to. So I don't want to apply this to all of these variables. I'm only going to apply it to views. So I'm only going to apply it to attribute number 5. So instead of first to last, which means all of them, I put in a 5 here. Okay, and then the bin range precision, I don't know what that means, but the number of bins, so I'm going to create a categorical variable with 10 categories, or 10 possible values. So I think that's all I have to do, and then click OK, and then let's apply it. So now if I go back to views, yeah, so now it has been changed to a nominal type of variable. Let's undo that to check that to see. Undo it. So, sorry, here's views. So it was numeric, but let me apply this again and go back to views. Now it's nominal. Okay, so the first range was -infinity up to this number. So it doesn't do such a great job, actually, because this is what? This is 33 million. So the first category is from -infinity up to that number. So that's that's much too big an interval at the beginning. So that's why we get so many in this bin and so few in here. So these are the ranges for the bins, or for the variables. So maybe there's some way to adjust this. Let's undo it. Let's go back here. I wonder what this would do. This says use equal frequency. That's probably not a good idea, actually, but just curious to see what that would do. Now if I go back to here, yeah, they all have the same frequency, but the sizes are not. They're different. It's hard to say. Anyway, I might not. You can see what happened here. We got all the same frequencies, but that made the sizes, maybe we could leave it like this, actually. As long as this is not what we're trying to predict. Well, anyway, maybe we could leave it this way. I don't know if there's any other settings that we could change. So this might be the best setting to use. Change that to true. So there may be some other ways to do this. So I looked up Discretize a variable in Weka, and there are some videos on this. So you could check those. And here's a question. How can I convert the numeric attribute into categorical? And there are 3 answers. So this one says you can use the Discretize, which is what we did. This one says, here's a tutorial on it. So this might be worth looking at. What's the other one? I missed one of them. But anyway, you can check to see if there are other ways to do this. And furthermore, even if you are not using, if this is not going to be your class variable, you still could discretize the variable, and then whatever your class variable was, you could still use this in its discrete form as an input variable. And it might be interesting to test, do your results get better when you do this, or do they get worse when you do this? Maybe you should discretize views even as an input variable, or maybe not. So you could test both ways and see which produces a better result. Okay, finally I want to remind you that sometimes Weka will work better with Excel files than with CSV files. Now, we've been opening the CSV files in Excel, but you might want to take, let's see, I need to get rid of something that I put here somewhere. Let's get rid of this. Let's just delete the whole column. And let's get rid of this, I guess, just for now. So delete it and save it. Or let's save it as an Excel file like this. So sometimes the Weka can handle files that are in Excel better than CSV. So the data, an error that you might get with a CSV file, if you save it as an Excel file, you might not get that error. So once you've saved it once you have an Excel file, then I've already done this, but remember that you have to go to here and Tools, Package Manager, and look for Excel. Enter. And I'm the available ones, but I've already installed it. So I'll click here and Weka Excel. So you can install that. I've already installed it. So now I can go to Open File. And if I choose, I have this option now, or this option. Okay? And I can open up Excel file. So if I open that, but sometimes it doesn't work. So sometimes it works better to open up an Excel file, and sometimes the CSV version might work better. Okay, so you might have to play around with that. So to review, first of all, we should try and get files that have between 15 and 25 input variables, or let's try to get at least more than 15. You can have a lot more than 15 if you want. And by the way, the main point of this exercise is to try and import your data, which you can see is not that easy, and not necessarily to do any classification. You can try to do classification, but I was hoping that you will look through these pictures and try to get some insight into the data from these pictures. So this is based then on deciding what is your class variable, Now, I don't have a categorical variable, which this is definitely not categorical. And none of these are really categorical. But let's say, so we could have made views categorical. In fact, let's go back and do that. Let's suppose, or category ID. Okay, let's use category ID as the, suppose we were trying to predict that. So I think this is currently numeric, but if I want it to be a categorical, I have to at least make it categorical. I don't have to bin it or discretize it because it's already discrete. This is only a few numbers, although I guess I could try and make it, well, let's say I left it as it is. Now, however, looks like there's from 1 to 28. That's quite a number of values, but let's suppose we did that. But one thing you should do is go to here and we want to convert it from numeric to categorical or numeric to nominal. So we look at this filter, numeric to nominal. Numeric to nominal. So now do we want to apply that to everything here? No. Only to, let's say, what was it? Category ID, which is the third one. So not first to last, but just the third one. And click OK. And apply it. And let's see. Okay, but they're all the same color. But here, they're not all the same color. So if I look at views, you can see that there's some variation in color there. Likes, dislikes. But the problem with this is that there's not much separation here. It's hard to say anything about sort of, since we don't get much separation, it's hard to get sort of interesting information from this. If you recall, if we go to Weka and open up data and the R files and the iris data, and we open that up, we can see here, for example, that the blue category, which we can check what the blue category is, it's the setosa. We can see that the setosa has mostly smaller sepal lengths, whereas this one, whatever this one was, you can check it, this is the virginica, has mostly larger sepal widths. So that's the kind of information that I'd like you to try and get from your data. Again, here we can see that this one, whatever it was, the blue one, the sepal width is larger than, say, the red one, and so on. So I want to get this kind of visual insight into the data. Of course, we can do classification and get some and build up some models. But for now, the main focus is on this and also just getting the data into Weka and choosing the data. And again, you're supposed to choose 2 different data sets so you get practice on doing this twice. And furthermore, when you write up your project, you should explain all the difficulties that you had in importing the data, in getting in converting data from numeric to nominal, in discretizing, or it's called binning the data, and explain what you had to do. Okay, and you can do some research on Weka on how to do some of these things as well. I'm sorry, on Google on how to do some of these things as well.